We're going to do the first part of 5.5. The most important thing you need to do is to draw a good picture. Let's look at example 1 here. The angle of elevation of a cliff is 39 degrees. So from the ground up is 39 degrees. And you are 49.1 feet from the base. We want to know how high is the cliff. Okay, using our trig function, tangent of a 39 is 49 point, no, opposite, is the cliff over 49.1, multiply both sides by 49.1, and so our answer will be 49.1 times tangent 39 is 39.76, or about 39.8 feet tall. The recommended safety angle for a ladder to the ground is 70 degrees. A 6.5 meter ladder will be used up the side of the building. How high will this ladder safely reach? Okay, let's draw the picture. In this case, we're given the angle. Oops, I gotta start that over again. The angle is 70 degrees, and the ladder is 6.5 meters tall. When you have an angle and the hypotenuse, when you have the angle and the hypotenuse, you can use the polar to rectangular conversion on your calculator, shift rectangular, and we've got a 6.5 meter at an angle, so shift comma, at an angle of 70 degrees, and we're going to go over 2.2 and up 6.1, 2.2 and 6.1. And that is our answer, 6.1. Next one. A roadbed rises 8.9 feet for each 113 feet of horizontal distance. We want to know the upward angle of the roadbed. So if you are given the adjacent side of 113.1 feet and the opposite side of 8.9 feet, you can consider this the x distance and this the y distance, and then we can use rectangular to polar conversion. So we want the polar form of that, shift polar form of 113.1 and 8.9. Shift. We want the polar form of 113.1, comma, 8.9, and we get 113.4 is the hypotenuse, and the angle is 4.49, or about 4.5 degrees. Next one. A ramp is to be built beside the main steps to the library. The total vertical rise of the steps is 3.9 feet, and the ramp will be inclined 4.1 degrees. Since we aren't given the hypotenuse, we can't use rectangular conversions. We're looking for the hypotenuse, so how long will the ramp be? Well, the sine of a 4.1 degrees is opposite, 3.9, over the hypotenuse. Or the hypotenuse is 3.9 over sine 41. So on our calculator, 3.9 over sine 4.1 is 54.5 feet. Next one. A forester needs to know the height of a tree. The angle of elevation to the sun is 34 degrees. She's 80.1 feet away. How tall is the tree? So, tangent of a 34 is the opposite, which is the height of the tree, over the adjacent 80.1. Multiply both sides by 80.1. And the tree will be 80.1 times the sine of a 34-degree angle, or about 44.8 feet tall. Did I do something wrong? Because I got a way different answer than they did. Oh, I pressed sine. I see what I did wrong. Tangent. So it's 80.1 times tangent 34. I don't know why I pressed sine. Is 54 feet tall to the nearest foot. Next one. A roof rises 8.7 feet and a run of 12 feet. And 12, what's the size of this angle? So we can use polar conversion because we've got the x and the y distances here. So if we put those into our polar form, shift polar, and we go over 12, and we go, oh, come on now, over 12, and we go up 8.7, we get 14.1 over, I'm sorry, the hypotenuse is 14.8 over, and the angle is 36 degrees. Next one. A screen for a radar antenna shows an aircraft. You gotta see how many there are here. (16.5 miles away at an elevation of 21 degrees. And this is 21 degrees. We want to know the height. This is a good problem for polar to rectangular because we're given the hypotenuse and the angle. So let's convert this into rectangular form. And we've got 16.5 and an angle of 21 degrees. And the x distance is 15.4. And the y distance is 5.91.